All right, so today we're going to be solving equations with variables on both sides. And here we go. Here's what we're starting off with. Something that's got a binomial on each side. Bi meaning 2. So we got a 2 terms on the left. We got 5x plus 2. And it's equal to another binomial, which is 2 terms, 2x plus 14. All right, so there's a couple different techniques you can use when you're solving these if you've done good in math and you do it your way. Some people like to move the smaller variable first. If you move the smaller variable first, more times than not, you'll have positive variables to work with, which eliminates a chance for an error. So the smaller variable here is the 2x. So I would subtract 2x from each side. So you end up with 3x plus 2 is equal to 14. Because obviously these go away. And then it becomes really simple. So if you subtract 2 from each side, and those cancel, your 3x is equal to 12. And you can divide both sides by 3. X is equal to 4. Good there? Good. Let's try another one. How about 7k plus 2 equals 4k minus 10. If you already know how to do these, then go ahead and finish it. All right? And then compare your answer to mine at the end, and we'll move through it that way. So right here, I would move the smaller variable again. So I'd subtract 4k from each side. So then that's a 3k plus 2 is equal to, be careful right here, that minus sign, that negative 10 comes down. A lot of people forget that negative sign in front of the 10. That means minus 10, and it also means negative 10. So now you got to subtract 2 from each side. And this is where a lot of you make mistakes again. You don't use your calculator, and you mess that up right there. Negative 10 minus 2. Those cancel. Your 3x is equal to 10 negative minus 2. That's a negative 12. You divide by 3. And your x is equal to negative 4. Say that again. Yeah, somehow k turned into an x, didn't it? So that's a k. There, k. All right. Everybody all right with that? Okay. All right, let's see. It takes a designer. $1.5 hours to make one page of a website. So it takes a designer 1.5 hours to make one web page. And I wish I could make a web page in an hour and a half. Took me like a month. Using new software. The designer could complete each page in 1.25 hours. Using new software, it now takes 1.25 hours. Oh, but it takes 8 hours to learn the software. That's a dilemma, huh? How many web pages would the designer have to make in order to save time using the new software? How many web pages would she have to design Let's see, this says in order to save time using the software. Okay. How many web pages would she have to design in order to save, I guess we'll word it, save time. And what does it all boil down to right here? Why would she want to save time? What's time equal? Time equals money. All right. And if you start off and you're charging someone so much per page for your website because it takes you an hour and a half, but then you buy some software and you learn that software and now you can cut that time down to 1.25 hours, you're making more money per web page, right? Because you're not going to lower your price. You're just going to get better or faster at making the web pages so that you can make more money. So that's the real question here. Not in order to save time, it's in order to make more money. So what's she saving each time? Let's see, she's got to spend 8 hours. So this is kind of a clue to this textbook and this class. If we just did 2 examples of problems with variables on both sides of the equal sign, and then you get a word problem, how do you think you need to set that word problem up? Probably with variables on each side of the equal sign, right? All right. That's the way the quizzes work. That's the way the study guide works. That's the way the textbook works. So this is kind of like, I don't really know how to set this up. Well, wait a minute. We just did variables on both sides. I got to make something equal to something else. Okay. So here's your setup. We're going to take this current design time, which is 1.5 hours, and we're going to make it equal to the new design time, which is 1.25 hours. Good morning. Yeah, you're going to sit right in that second seat, the one you just walked by. Thank you. Let's see. We're going to make the current design time equal to the new design time plus this 8 hours that it took you to learn the software. So let's solve for this h here. All right, so we can subtract this 1.25h from each side. Say again. (1.5 minus 1.25), that's 0.25. So 0.25 h equals 8. Divide by 0.25. And h equals 8 divided by 0.25. That's what, like 32? 32. So it's going to take you 30. So your break even becomes 32 hours. Does that make sense? So if you take the 32 and you divide it by, because the question was, how many web pages would she have to design in order to save time? It's not going to, it took you 1.5, and then it's going to take you 8 hours, and it's going to take you, because hopefully you're going to keep designing web pages as you're learning the software. Because it's going to take you a little while to get down to the 1.25 hours per web page. But it looks like your break-even point is 32 hours. So that's just a decision you got to make. Is it worth it to spend those 8 hours to save 15 minutes per web page? That's what you got to decide. Good there? All right, let's take a look at a few more examples. We got 2 times 5x minus 1 now. And that's equal to 3 times x plus 11. So this is a distributive property on both sides problem. You got to distribute this 2 first. So you got 2 times a 5x, which is 10x. And 2 times negative 1, which is negative 2. And then you got a 3 times an x, which is a 3x. And you got a 3 times an 11, which is positive 33. And hopefully you can see what's going on there. The book just keeps adding one more step every time they show you a new type of problem. All right. So now if you move the smaller variable, you can subtract 3x from each side. So 10x minus 3x, what's that? Good. 7x, then minus 2 equals, this goes away and the 33 comes down. Then you can add 2 to each side. And 7x equals 33 plus 2. Good, that's 35. And then you can divide by 7. 7's cancel, and x equals 5. Let's try a 7 times 4 minus a. Equal to a 3 times a minus 4. All right, again, distributive property on both sides. Be careful with these signs. All right, you got 7 times 4, that's a 28. But then a 7 times negative a, that's negative 7a. On the right-hand side, you got 3 times a, which is 3a. And then you got 3 times a negative 4, which is a negative 12. And now your smaller variable is the negative 7a. All right, this will stay way cleaner if you move it, meaning you add 7a to each side. So then your 28 falls down. Your negative 7a and positive 7a, they cancel each other out. 3a plus 7a is 10a. And this negative 12 falls down. Now you can add 12 to each side. And 28 plus 12. Good, that's 40. And then you divide by 10. So 4 equals A. Questions? All right, a couple more examples to talk about. We're going to talk about here, this is called identity and no solution. Identity and no solution equations. So let's take a look at 10x plus 12. Ten x plus 12 is equal to 2 times 5x plus 6. All right, so this is just distributive property on one side of the equation. So look, you got your 10x plus 12. That's just, I'll rewrite it. Then you got your 2 times 5x, which is 10x. And you got your 2 times 6, which is positive 12. And now you got the left side equal to the right side. Agreed? So anytime that you get to an equation where the left side is exactly the same as the right side, I mean, you can keep going with this. You can subtract 12. You know, maybe you haven't noticed it yet. And now you get this cancels and you get 10x equals, you bring down your 10x and this cancels and 10x equals 10x. Left side equals the right side again. When you get to that step or stage of the equation, you just stop and you write the word identity. It means no matter what number you put in for x, it's going to solve the equation. If you put a 1 in here for x, you get 10 times 1 equals 10 times 1. If you put a 2 in, you get 10 times 2 equals 10 times 2. It's an identity problem. All right? Sometimes it's followed up with this. Identity, here's the symbol for infinite, solutions. You may see that either way on your study guide or quiz. You may see the answer as identity, or you may see it as infinite solutions that mean the same thing. There's an infinite number of values that you could substitute for x that would still make this equation true. These problems up here that we had been doing in the past, this is a one solution problem. X equaling 5 is the only value that will make this equation true. When A is just equal to 4, again, that's one solution. All right? You may get a question on your study guide tomorrow that says something like, determine the solutions for the equation. So you solve the equation. And if A is equal to one number, then you could say that there's only one solution. If, as you're working through the problem, it turns into an identity problem, then that problem has an infinite number of solutions. All right? And then the last example we'll do here is when there's no solutions to an equation. And let me see if I can. All right, here we go. 9m minus 4. 9m minus 4 equal to negative 3m plus 5 plus 12m. So this left side is pretty much simplified. There's not much to do to it. There's no combining of like terms, and there's no distributive property. So I rewrite it. And then on this right side, you can combine this negative 3m and this positive 12m. So negative 3m plus 12m is 9m. And you can drop down this positive 5. And now is when you need to notice that something doesn't look right. I don't know how a 9m minus 4 could equal a 9m plus 5. Right? I don't know if that makes any sense to you or not. But let me show you one more step. If we get rid of the 9m's right here, say you subtract 9m from each side. The 9m's cancel on the left, and you get left with a negative 4. The 9m's cancel on the right, you're left with a positive 5. And I don't know where you went to elementary school, but where I went, negative 4 don't equal negative 5, or negative 4 don't equal 5. When you get to that step in an equation, or this step right here, where you had 9m minus 4, 9m minus 4 equals 9m plus 5. That don't work, does it? That doesn't work. That can never be equal. This can never be equal. And when you see either of those things happening in a problem, you can stop and you can write no solution. There's nothing you can substitute for m to make this equation be true. That makes sense to everybody? Okay, so if there's no questions from you people in the class and there's no questions from you people at home, I'm going to give you some practice problems to do today. Now, you people at home, your practice problems, I uploaded a couple of PDF files to the resources tab on Focus. That's where you will find your problems for today's assignment. The people in class, I'm going to give them a handout. All right, so today's practice, all right, your practice for today is on page 106. All right, and I want you to do problems 21 through 36. You need to show all your work. If you're in class, you're going to drop it in the basket. That's upon a departure. If you're an e-learner, you are going to email a picture of your work by This is over at 10:07, right? Email a picture of your work. By 10:07. Don't send it to me tomorrow. If you were here today and you got the lesson, your assignment is due at 10:07. Whether it's complete or not complete, you send me a picture of it via email. I gave you my email address. All right, here it is again. No. Let me finish writing this so I don't get confused. No, if you're in class, you do the work on paper, you put it in the basket. If you're an e-learner, at 10:07, you set your alarm, or if you finish before 10:07, you take a picture of it, email it to me. If you're still working on it at 10:07, you take a picture of it and you email me the picture of what you got done today. Clear? Anybody got any questions on any of that? Yeah. 21 through 36. I haven't handed out page 106 yet. I'm getting ready to. No, you're not. That would be too easy if we could actually use a textbook, because then I wouldn't have to go make copies all the time. All right, so I'm going to stop.